WhatsApp. So thank you for the confirmation. I appreciate it.
No worries.
They've got quite a spiel that they would like me to go through before I introduce you. So if it seems like it's running long, it is.
Like,
Basically,
don't.
there's a lot of text here. So I may take a little bit of creative freedom on it and cut it down a little bit. But I guarantee you, Test 1, 2. All right. Excellent. Hopefully that was a momentary blip. I have no idea if we're streaming live yet. All right, we are a go. Hi, everybody. My name's Dan from Datadog. I am pleased and honored to be helping out with this third very special edition of DevOpsDays Kyiv from home, a special event for a special time. This is the second day of 3 days of live streaming on YouTube, Facebook, Twitter, Twitch, all your favorite places. We have a ton of good material that we've already seen yesterday. We're going to see a ton more today and a ton more tomorrow as well. Of course, hey there, everybody. Hopefully we're back on. Looks like I'm having a couple of minor problems connecting to the streaming platform. Hopefully those are just some temporary hiccups. Where was I? Ah, yes. Because this is all on social media, we're on the YouTube, we're on the Facebook and everything, it's incumbent upon me to ask you to like and subscribe. All right, great. Is my video working? I'm getting mixed results here. All right, let's try this one again. Hi, everybody. My name's Dan. I'm from Datadog, and I am pleased as punch, just absolutely honored to be participating and helping out in this third very special edition of DevOpsDays Kyiv. This one's from home, a special event for a special time. This is the second day of 3 days of live streaming on YouTube, Facebook, Twitter, Twitch, all your favorite places. We have a ton of great material we've already seen yesterday, a ton of great material we're going to see today and tomorrow as well. As I said, it's 3 days. It is social media, so it's incumbent upon me to ask you to like and subscribe. So please go ahead and do that now if you haven't. All right, great. Yesterday, we had a great intro talk by Baruch and Leonid, and an excellent technical talk by Chris Nova, who really just dove into some really key concepts in the security world. So thanks for that so much. Today, another great lineup. We have 2 talks. Niall Murphy from Azure, whose name you may know, and of course, Liz Fong-Jones from Honeycomb, whose name you may know as well. Tomorrow, I will be sitting down and chatting with Kelsey Hightower, another name you may have heard of. So again, a lot of great content coming your way today and tomorrow. One thing I'd like to get out of the way right now is that this is the internet, and this is a very strange time for people on the internet. And because it's an online event, things can go wrong. We've already seen it a little bit today, for example. So yesterday, we had a bit of an interesting incident. The DevOpsDays Kyiv team would basically just like to extend their apologies for some of those issues that occurred yesterday. Now, in the interest and spirit of DevOps, we'd like to just share with you what happened yesterday and what steps have been taken today to try to make sure that the experience is as fluid for you, the audience, as possible. So let's just be honest, right? Sometimes things break. In fact, failure modes are sometimes the default modes. So what the DevOpsDays Kyiv team has put together today is basically a multi-region, multi-cloud setup, right? They've taken into account bus factor, communication situation, ethical situation, and have tried to build something a bit more robust to deliver the content. But of course, again, things can go wrong. What they've done today is that they've analyzed yesterday's incident. They did a blameless postmortem, right? Again, this is DevOps Days, and found 3 possible ways to resolve this inconvenience. Basically, they went for what they believe to be the most reliable. So there's 2 independent groups of technical staff in 2 different home offices, running on 2 different internet providers in 2 different Kyiv regions, just in case there are electricity issues, okay? If something goes wrong, it'll be possible to continue streaming from another location. The SLA is apparently of 1 to 3 minutes, so that's very good. And if you don't know what an SLA is, perhaps that question will be answered either today or tomorrow in the talks. It depends mostly on how fast the speaker and the moderator can rejoin the stream. And we've actually already tested out that a little bit today. So as we can see, it's a relatively quick turnaround in the case of small internet blips. Also, we've asked everybody to test beforehand. Everything seems to be working. And where possible, some pre-recorded talks. So that's fantastic. We're going to have a live Q&A session. That live Q&A session is going to be live. So hopefully we don't have any blips on that one either. All right. Why are we doing this online? If you've been to DevOps Days before, you know that it's a great in-person event, right? Hallway track is fantastic. The networking is fantastic. The attitude and the personalities and the spirit of DevOps Days is one of open communication and just getting together and sharing. Unfortunately, in today's extraordinary times, we were unable to provide that in-person experience. Fair. And that's why we're doing this online. It's easy enough for us from the comfort of our own homes to participate in this event. And so on behalf of DevOpsDays Kyiv and really just everybody, we'd like to say thank you to all of the brave people who are putting their lives at risk every day. And that's emergency workers, doctors, all the way down to people that are driving trucks, fulfilling orders, working supermarkets, whatever that means. If you're getting out there and doing work, thank you so much for continuing to support humanity. Let's call it what it is. As you know, people around the world are unfortunately falling ill, and more than 1,000 doctors have contracted the disease in Ukraine alone. And there are people who need help and need your support right now. So I would like to announce a small charity project. All right. Any money that's donated through the charity project, this Ukraine event, will go to help people in the Ukraine who are, again, putting their lives on the line. We're going to have some more information about that in the YouTube video description. So if you are able and if you are willing to help out not only first responders, but everybody, again, who's keeping the country running, please feel free to do so. All right. One more bit of housekeeping before we get on the way. We have a job board. All right. This is one of the cool things about DevOps Days Kyiv, the in-person format, and now on the virtual format as well. We do have a job board. If you're looking for a job, you're looking for a long-term thing and some gig work, go check it out. Again, that's going to be in the YouTube video description. All right, so hit that up. It could be your next excellent opportunity there. I mentioned a little while ago that we are going to be doing a live Q&A. All the live Q&A is going to be performed through an online application called Slido, sli.do. It's fairly straightforward to use. We use it at DevOps Days Paris as well. So we're going to be dropping that into the chat. So if you're watching on YouTube, it's going to be dropped into the chat. Each of the speakers has their own Slido. So there will be a Slido for Niall and a Slido for Liz. Again, that's going to be dropped into the chat. If you have any questions, don't wait till the end. Just go ahead and ask those questions, pop them right into the Slido, and then those are going to be filtered up, and we'll ask some of them at the end of the session. Between the presentations, or even during the presentations, and the short breaks, and after the presentations as well, we do have some Zoom breakout rooms. If you just want to chill out, get some hallway trek in with the other audience attendees, it could be a nice opportunity to just meet some new people or see some familiar faces. That's all on the DevOps Days Ukraine, or DevOps Days Kyiv website as well. And that link is also going to be dropped into the YouTube chat as well, so don't worry about it. Okay, without further ado, I am pleased as punch to be welcoming our first speaker. Many of us feel passionately about the Site Reliability Engineering book and its accompanying work, the Site Reliability Workbook. I know it's been a reference material of mine for some time. In our minds, we may think that these books are written by anonymous people at some large company, by Google, for example, and only a few of us ever get a chance to see the real people behind that by Google. So in this case, I am proud to show you the real Niall Murphy, now working for Microsoft, who was instrumental in making the Site Reliability Engineering books happen. So without further ado, warm round of virtual applause for Mr. Niall Murphy.
Hello, everyone. Thanks for tuning into the talk. This talk is called Mental Models for Reliable Software Engineering. My name is Niall Richard Murphy. I work in Azure Site Reliability Engineering, and you can get me at niall@microsoft.com, or I'm niallm at Twitter. So I don't come from a DevOps background as such. Might not have heard of me. You might be wondering what I'm doing here. Actually, the first thing to say is I'm honored to be asked to I have been thinking about the problems of reliability in software and system, and indeed cultural transformations for a long while, a lot of which I think are issues that overlap strongly with DevOps areas of concern. But if you have heard of me, this is probably why these books, and in particular the Global DevOps Bootcamp keynote last. If you haven't heard of me, or if the term SRE scares and confuses you, or if you're wondering what this has to do with the lived experience of a production-minded developer on a team, don't worry, we will deal with that very shortly. So I think people often talk about SRE, Site Reliability Engineering, as if it came out of nowhere or a very specific place, or there's no real overlap. That's not really true in my view. In my view, they both spring from a kind of a similar dissatisfaction with the state of the world, and in particular, the state of how most organizations handle the question of operations or silos in general, but definitely specifically the interaction between product development and operations. So it's well known, I think, that operations is a hard problem. Lots of folks have tried to solve it. There's academic discipline dedicated to it. It does slightly depend on your definition, I suppose. There might be a bit of wiggle room there, but broadly speaking, operations is hard. Lots of different approaches to this. We call out ITIL, DevOps, SRE. For the purposes of this talk, I'll say DevOps is a philosophy, SRE is a discipline, a job. Bit more tight on definitions of some things, a bit less tight on others. I will say both of them, certainly from my point of view, care very much about culture, measurement, lean, efficient operation, the CAMS acronym underpinning of DevOps. The one difference I will highlight is that SRE is kind of sort of like DevOps, except it's more kind of production oriented, shifting left over to the design phase of the SDLC. And DevOps is more feature focused, shifting right to production, or more code or product focused, possibly is one way to. Hat tip to Tom Limoncelli for this definition, which I think surface some of the differences between DevOps folks and SRE folks you might encounter in the real world and what they're actually doing on a day-to-day basis. But there's actually a lot more in the article linked there, which is DevOps article in the SRE workbook. So check that if you want to know more. But that's the basic for what we're going to talk. Wiggle room aside, the initial SRE, very, very first set of people were just people who cared about production slightly more than the other engines on the search. So they more or less self-selected into, and that matches some of my experience and my intuitions about DevOps. Similarly for Microsoft, while we have folks who do horizontal under the heading of SRE, we also have folks who work quite closely in a feature team scoped, except they're working items to do with reliability and other non-direct feature. Of course, there's always a question of what the definition of a thing might be and what changes after marketing happens to that thing, but we'll leave those aside for a moment. So speaking of definitions, probably an appropriate moment to look at definitions of SRE, just to frame the rest of them. In this definition, which is the Azure SRE specific definition, obviously your mileage may vary. What I would say is that we tend to look at SRE as an engineering devoted to helping an organization sustainably achieve the appropriate level of reliability in their systems, services, and different words are carrying a lot of weight there, and emphasis matters. So engineering, of course, is part here. A couple of the important words I would surface from that are sustainably and appropriate, and obviously reliability, of course. Get onto that in a little bit more detail on. But having decided reliability is important to you, you have to figure out what the appropriate level of reliability is. And not only that, because that answer might vary, obviously, depending on product, organization, etc., but to help an organization sustainably achieve that, i.e., not throwing people at the problem in order to service or system continue to operate. And in general, this means software supporting the reliable operation of software, which is the key to scaling and the key to, in many cases, reliable operation. So let's talk a little bit about the premises of this conversation. So, mental model point of view, what am I talking about here? I think the first thing to say is that the art of making good software and good systems software obviously relies much more than simple. So the key to successfully making good, reliable software is, on an organizational basis, is understanding what mental model of this activity the various staff have, and approaching them, asking them questions and saying things to them in a way that, for example, do all of your stakeholders even think about reliability at all? Maybe. Or if they do think about reliability, do they think it's important? Where did this? How important is it compared to other things? Many years on, I think from the emergence of DevOps as a concept, there are many organizations that are still struggling with it as an idea, struggling with various conflicts inside organizations that limit it, and even more fundamentally with the idea that holistic views of the software development lifecycle are useful. And so I won't really talk about the technical side of mental models for reliability and how to design with failure in mind. The previous Global DevOps Bootcamp keynote has about that, and there's a very large amount of collateral for that if you want to look at it. This is more about how to bake reliability in as a first order concern in your operation. And for reliability, I think reliability is important. I think customers do as well. There are also other properties, security and so on, that you might want to add as significant items of concern within your development process that don't necessarily get all the attention they should today. So for today, some of the key questions. First one being, why care about reliability? I mean, if your customers are going to get, doesn't matter how long your systems, well, they're more complicated than that, of course. If the systems are down, the software has no value, as Andy is fond of saying, said so in the workbook. Reliability also as a thing in general, I think of it as being quite customer friendly, because it's user oriented. If the thing isn't responding correctly, the product isn't. It's complicated and difficult to do well, right? It might even be an emergent property in some properties that you might desire, attributes you might desire for your software that could fit under that head of security in particular, not being conventionally understood by those close to it as a Boolean. You are or not secure, but maybe is more of a. But I think my sense is in a professional software development, most people, when they are concerned about questions of reliability and basically non-feature driven development, asking themselves questions like, how can I get this work prioritized? How can I get it prioritized within my organization? Really the thing. So according to this view of the world, as well as operations being hard, which we there, software is also hard, as well as yield. We said earlier, software is also hard, as well as eating the world. Software is hard. And so in this theory, or in this view of the world, when you're in transformation, what matters is really the mental models of the people doing the transformation, or in some cases, not doing the transformation. And sometimes they might have a more accurate model of the act of doing software appropriately within your organizational context than you do, or maybe not. In particular, I guess the question is the model of software development. What's it about? What are you really trying to do? How should it best be done? Often reflecting itself in questions of prioritization, etc. So let's start off with what I'll call the null hypothesis, the thing which has to be rejected in some readings of the statistical term, or maybe even a market-based hypothesis is a slightly better one. So in this model of the software development process, nothing matters except feature development for revenue capture. There's the thing called technical debt I've heard of. We don't pay it unless it's utterly unavoidable. And we avoid treating with anything else, if at all possible. There are less intense varieties of this particular model available, and sometimes it's a question of prioritization, of course. But like any model, it has some strengths and weaknesses. I think its primary benefit really is that it's extremely focused. There isn't really a doubt about what's valued in that situation, and that in itself is actually a benefit, provides organizational clarity. I think it has a significant number of weaknesses, though. Primary amongst them that I'll surface in this talk is a very interesting paper from Microsoft called Online Experimentation at Microsoft, which suggests that when we're doing feature development for revenue capture, actually not all of those features are equally revenue capturing. and we're actually not very good at figuring out which of them is going to work for revenue capture, and we're probably about as bad as figuring out how much revenue capture we'll get from them. The data in the paper, which I strongly encourage you to go out and look at, suggests that actually on a pure numbers volume basis, when you're doing revenue capture via features, about 1/3 of those features actually have a negative impact. Now, it might not be as severe as you do a feature and actually it loses you money. It might merely be you spend time and energy on that feature, which turns out to do not very much for you, and so it's a total negative. The total cost of it is negative. But actually about 1/3 of the features that get developed are neutral, like revenue neutral. Maybe they paid for the cost of the development team time, or about that. And it's only 1/3 of them that are really revenue positive. And some of those are, you get extraordinarily lucky and featured very, very popular, and it's one of those famous 10x style experiences, but most of them aren't that, particularly in the context of online services. You're lucky to get kind of single-digit percentage boosts out of relatively mature products with new feature launches. Another, possibly even more fundamental question is the question of measurement. When we engage in the idea of revenue capture by feature development at all, we have to measure something, and in order to say that we're doing this successfully, and not all of those measurements are actually correct or useful or easy to put together, et cetera, et cetera. My favorite example from a related paper at the online experimentation website is the statement that users that see more error messages in Office 365 also churn less. So therefore we should show them more error messages in order to get them to stay even more strongly with the product. So obviously there's a correlation, not causation thing going on here. But I think taken together, the fact that we're not necessarily sure how effective any particular piece of work is going to be, particularly in the revenue capture domain, and 2/3 of them, like based on this data, are potentially either bad or just useless for you. It might open up possibilities to ask serious questions about prioritization. Are all features equally valid? Well, the data suggests they're not. And it's equally valid under the heading of revenue capture, right? There are other headings under which they could be evaluated. One which is even more apposite, perhaps, is does every feature piece of work override every non-feature piece of work? Are the results of this work as measured causal and not correlative? Is revenue capture better, absolutely better, than revenue loss prevention in every case? I think many folks would understand that over time, these questions are actually become of critical importance. Being able to answer them successfully for your particular context is of critical importance. As I say, it's not a super realistic model, since most professionals at some stage, even most decision makers, accept that you can't just do features all the time. But our understanding across the industry of the appropriate ratios for this, I don't think they're very advanced. We don't really have a good nuanced understanding. We don't even really have a strong set of rules of thumb. The closest I've come to this professionally from the rule of thumb point of view is that an SRE organization should be about 5 to 10% size of a product dev organization. for which there's basically no hard evidence that it's true or strongly related to questions of technical debt. But anyway, let's go on. Move on to another historically popular model, hard boundary model. So we accept in this model that things like incidents and technical debt exist, but we try and get somebody else to handle them. We're basically putting a partition between folks who work on features and folks who work on more or less everything else. And this way we're hoping to get large or better feature velocity or somehow insulate folks from each other. So, I mean, like every model, this has strengths and weaknesses. I suppose from my point of view, the strengths are the sharp lines of maybe its authority, but certainly its kind of organizational responsibility lead to clarity. Clarity is important. It's a model that can be cheaper to run, possibly related to outsourcing as well. But on the other hand, the set of weaknesses are really very, very large and important in my point of view. Probably don't need to spend a lot of time going over this in a DevOps context. But basically every team in modern software development, best practice relates to feedback loops of one kind or another, broken, right, in this case. There's also questions about lack of parity of esteem, encouraging finger pointing, latency of delivery of features because of kind of organizational paralysis. Ultimately worse for customers, really. And I suppose that a cost center focused view on IT often ends up having agility related consequences. My favorite book in this respect is Accelerate by Forrest Green and Humble and Kim et al., which I strongly recommend you read just generally and also specifically on this topic. I think interesting questions to ask about this model, and when you're trying to perhaps investigate an area of the organization that has this model or trying to commute hopefully away from it, what is actually better for the customers and the staff than this model? Are there alternate models available? Do you have a measurement culture and the measurements themselves in place to understand what you're doing and how you're doing it? And this is where Accelerate is great, because it's got really sharp definitions and actual outcomes relating to survey data, which can be flowed straight into these conversations. Another key question is, why is cost central to these discussions rather than value? And the interplay between those two can be a very good conversation to be in. I suppose ultimately that a relatively objective evidence suggests that being better at the business of software, particularly with respect to time to get to prod, features to prod, means that you're better at business. Never mind the business of software, but you're better at the business, full stop. And like, why aren't we doing that, or why aren't we in a position to do that? So the next model is another well-known model. Oh, model 3 actually, sorry. You build it, you run it. So in this case, for the purposes of the talk, we'll say this is akin to the famous Amazon two-pizza team arrangement. You've a smallish team, they've developed a thing, they run a thing, and perhaps it's behind some kind of information hiding RPC interface. The important point from this point of view, or the important attribute from this point of view, is you keep all of the responsibility in-house. So again, like every other model, it's got strengths and weaknesses. The nice thing here, I suppose, about this model, set of nice things are, there's no avoiding feedback loops, right? You cannot hope to avoid in a systemic way the consequences of your own design decisions if you're on this team. Eventually the operations on-call schedule will come around and you will learn about what it was, the value of the decisions and the implementation that you made earlier on. And that's a fantastic strength. I mean, I hope I'm not alone in believing that well operable software is just kind of good software inherently. But you also have in this model the freedom to reinvent an implementation behind a designed interface. Now that's, again, kind of flowing from the Amazon model. That doesn't necessarily pertain in all circumstances, but the you build it, you run it approach does stimulate a sense of ownership, which can mean that the impetus organizationally to change implementations behind can be stronger than in the situation where ownership is partitioned. I'll say that rather than spread or diluted, but ownership is partitioned, and organizations can end up fighting each other about change. Ownership also makes it easier to build career paths. I think also makes people better engineers because they have to think more about what they're doing, and they get to see the whole life cycle of a thing. And sometimes when you're seeing a short window of a thing, you don't have enough time to build a strong model about what's going on and what it means to be good at doing that thing and seeing it through to completion. But having said that, there are actually a number of weaknesses to the model as well. And I say hard to get past the RPC interface on the slide. I suppose what I really mean is that teams that are far apart organizationally in this strong ownership, team level ownership model, they almost never consolidate expertise, right? There's hardly any organizational benefit to them doing so or any real rationale. You've always got stuff to do in your own domain. And what that leads to is, 17 different teams reinventing key value bearer systems or bad backstops or whatever. It's kind of team optimal and company pessimal as a setup. If duplication of effort is your thing, and if scale of operation is your thing, it's not very good about that. And there are other questions as well, which I suppose can lead to weaknesses, such as if you didn't build it, but you're told you have to run it anyway. That's also not great, particularly for the people who have to do the running. Or what if, possibly as a result of this, no one wants to run it? That model kind of works for an underlying set of assumptions about software development and organizational competences, etc. And exceptional situations aren't necessarily handled by it very well. Another point, I think, possibly also related to other conversations we're having in the industry about diversity of backgrounds and concerns and so on. A very, very coarse one I will use as an example here is systems versus software development expertise. It can make it hard in the case where basically you have everyone on the team being a strong software engineer, apart from somebody you've brought in to with some particular strong piece of expertise. Can make it hard to reward the right behavior, depending on the situation and the context, of course. But my experience is that diversity of background can sometimes be hard to facilitate in strongly focused ownership models. And obviously questions that are particularly relevant in the DevOps context are how is this model compatible with the no more silos? Basically isn't, right? It's silo generating, like many other things. And how easy is it to share expertise? Obviously, a decision maker might say, how much does that matter to the company overall? But my sense is that when reliability is a concern, that kind of thing does really matter quite a lot. Other questions are, is the right mix of people on the team? Can they be kept on it? And so on. Not all of these are exclusive questions to the strong ownership model, but I think they're definitely related. So talk a little bit about the SRE model. For the purposes of this conversation, I fully and completely accept it can be done in a million different ways. But for the purpose of this conversation, I'll say an SRE model is a separate organization in terms of reporting chain with expertise and kind of shared systems, reliability, and domain-specific concerns like that. But they partner with a product development team very closely. So this model also has strengths and weaknesses. It is a good way, a separate organization that's not driven by pure feature concerns is a good way to keep people working on reliability even during times of feature pressure. So it's a good way of raising the floor on a system and making sure that the worst outcomes can't happen to the extent that they would flow from people taking their eye off the ball. And it's an emerging, exciting job role. So lots of people are interested in it and want to do it. Weaknesses, obviously I'm very biased in my approach here, but I'd say that there's a lot of people say that there's a question mark around the scale that you can get that kind of thing to operate in, like you have to be a large company in order to do it. Personally speaking, I don't know about that. I've done a few talks on how it's possible to be an SRE at a small company, and SRECon has a number of talks like that as well. I think being reliability minded is a thing which can happen no matter what your job title is or no matter what company you work at. And I think that's more fundamental than whatever we call the job role or hire a person as. And I think another weakness of the model is that if there's literally no shared systems between the teams, then we're relying on relatively generic expertise about reliability, and transferring between teams is more or less the same as hiring a new person. And maybe that's less good for the company as a whole. Also, a number of questions we can ask about maybe existing implementations of SRE within a company, or planned implementations of SRE. You know, a very famous one would be, is your SRE team actually an SRE team with the authority to do what's right, or is it a renamed other department with nothing else changed? That's happened a number of times in the world. And starting a new SRE team obviously involves significant disruption, particularly when authority is kind of being diluted or shared, probably the right word, rather than partitioned. Anyway, it often involves significant disruption. So do you have bottom-up and top-down support for what you're doing? Because you'll need both. Are you in a position, harking back to the previous definition, to understand the appropriate level of reliability for your systems? Do enough people want it, that level of reliability? So all of them good questions to ask. But now, to finish up, just want to talk a little bit about one of my favorite books, Switch, How to Change Things When Change is Hard, by Chip and Dan Heath. I strongly recommend if you are involved in change within an organization of more or less any kind, you give this a read. I find it a very positive, motivating read with a lot of successful stories and interesting things to learn in it. Certainly my interpretation is that more or less anyone in the DevOps world is interested in change, organizational change, one kind or another, in a way that maybe other folks aren't. But anyway, in this book, and again, I should start off by saying that there are very, very many change management models in the world, and in books and in academia and so on. And there's even an article in the SRE workbook about change management, which makes reference to a number of these things. But in the change model world, like, the number one question really is, how do you get things to change? And in this book, they talk about how when you're trying to drive a change, you need to get the heart and the head and the environment cooperating for actual sustained kind of change that sticks, really. You have to address things in the emotional domain, and you have to address things in the kind of rational or intellectual domain in order to get stuff to stay. In the emotional domain, I suppose, habitual behaviors, the idea of collegiate or kind of group membership and identity. Who am I? What am I? What is my role? I think of myself as a blah, which will make it hard for me to do this other thing over here. The fact that psychologically speaking, there's some good results, or I should say strong evidence suggesting that human beings are very loss averse, loss oriented, loss sensitive. So if you're taking something away from them, they'll react much more strongly than if you give them something, bizarrely, but it's apparently true. Communication as well, that could also go under the rational domain heading there as well, but good communication to the individuals involved and repetitious communication and so on are all completely necessary for any kind of decent size change project, or even any change project at all, really. You also need to address things in the more rational domain. And I feel that by default, many organizations end up kind of defaulting to, we will tackle this in the rational domain, and we will fix the incentive structures, and we will change the organizational structures. Hooray, reorg, and we'll have a new strategy and direction and the document which will explain everything. And what we often end up finding is that if you don't couple these together while also tackling the question of the larger environment, then your change project is much slower or doesn't go anywhere. And I suppose one of the main techniques, we'll talk a bit more about the techniques in a moment, but one of the main techniques I've been mentioning throughout this presentation is asking questions. How do you ask appropriate questions in the appropriate way? And in many circumstances, particularly when environments are kind of low trust or loss averse or similar, you have to ask questions about where an organization is and why it's doing what it's doing in a non-threatening but kind of energetic way, in order to start folks thinking about what they're doing and why they're doing it, but not in a way which is going to cause them to want to block something. So you need to be non-threatening but energetic. And so one interesting way to do that is to be value oriented and talk about benefit to the customer, because that's an argument that it's kind of hard to comprehensively fight against, I suppose, and certainly be seen to be doing the right thing. There are other techniques as well. One of the ones I mentioned in the book is to encourage bright spots, more or less on any scale, like maybe not the very, very tiniest, but in an organization, in a team even, there's usually places where the right things are happening. And you need to connect those places or those people and advertise those widely around the teams, the org, etc., in order to help create momentum for a change. Another key point is that smaller programs are usually nimbler and more resilient than kind of boil the ocean style projects. You may have a boil the ocean style transformation in mind on any level, really, but you're probably best off starting with local value, like value delivered close to a team with committed individuals, and an experiment that's easy to start and in the minds of others easy to change or stop if it's seen to be not working, but delivering value quickly is good. Another point, probably oriented towards the communication piece is making changes concrete and shrinking them. So you have to be as specific as possible about what the feature looks like on a per team basis. As specific as makes sense, really, because it won't necessarily be clear for every team, but you have to be as upfront about it as you possibly can. And also making the intermediate steps easier and shorter, often by having somebody kind of interpret or break down the steps between the glorious future and the uncertain now, and add those concrete steps with kind of rough timelines. Like usually people will buy into something even if not all of the I's are dotted and T's are crossed, as long as you have a reasonably articulated version of the feature and some semi-plausible steps on how to get there. I mean, we work in software, we're used to things not working, used to things changing rapidly, and most people would recognize that. But going the extra mile to do those things can win you a lot of support. And also a very important lesson that ambiguity causes hesitation, causes people to go, well, what is the highest priority actually? You told us X and then you told us Y and then you told us Z, and somebody turned around the other day and said it might be A. Ambiguity causes hesitation. So you need to communicate frequently, even the bad things, possibly especially the bad things. Then people have a much larger chance of figuring out in their own local context what it is that they should do. So just to end with the summary. So approaches to implementing reliability mindset in your software and systems almost always involves dealing with people and often changing their minds and behavior. And people have models about how the world works and how the process of software development works and how software is done, which drives their reactions to change, proposed changes to how work is conducted. And a lot of those models are actually somewhat or mostly on an intellectual level of some kind, but people also have emotions about things, feelings about things, and their emotions make them do things, react in particular ways, etc. So you can change what models people use by examining the strengths and weaknesses of them in a relatively neutral way, in an open way, and asking good questions about the cost and benefit. And a successful change project involves emotional negotiation, intellectual support, and environmental hacking. And thank you very much.
Thank you for that. Super interesting, honestly. It was really, just on a personal level for me, very interesting to see how the discussion around these subjects has evolved, certainly from your standpoint, but also from an industry standpoint over time. We do have a couple of questions. Do you have anything you'd like to say before we dive into the Q&A, sir?
Yeah, I suppose the first thing to say is thank you to the DevOpsDays folks for their extraordinarily good AV support, which swooped in and saved the day at not the last moment, the couple moments before the last moment, but very much appreciated.
Excellent. Well, I'm sure they appreciate that. And of course, it's tricky stuff, right? So that they were able to respond that quickly, I suppose, is a testament to DevOps practices to a certain degree. Excellent. So we do have a couple of questions here. One of your slides, you were talking about features and ways of determining whether features were all equally valid. Just curious, what would be some ways to make those determinations? You posited the question. I'd be interested to know if you have potential answers to it.
Sure. I suppose the number one thing to say is that when you've been in a number of large organizations, as I have, large software-oriented organizations, you get to understand that different organizations can have pretty different ways of ranking things and ranking the success of things. And often smaller organizations or startups don't have that kind of luxury. It's about the dollars. We get the dollars in the door and that's a success, or we don't get the dollars and that's a failure. But more or less when you're beyond the immediate kind of we need to get the dollars in the door and nothing else matters, you end up having a very large array of things that you could use to judge the validity of features. And they can be stuff like infrastructure work, scaling for future success, or adoption, scaling of adoption, which drives product growth so that then you can later turn on the dollar tap more effectively than you could if you just turned it on earlier, and so on. Like, there's actually a very large variety of those. And I think the point about the paper that I was talking about, the online experimentation paper, is that actually none of these ways are really very good. Maybe the truth is in between, or a combination of these, or you have to figure out what works in your own situation, or similar weasel words, right?
Right. That's good. Yeah, and that's fair, and I appreciate that. That sounded like an honest answer, which I appreciate certainly. So we had a couple of questions coming in on Slido, so thank you everybody on the YouTube chat for using Slido to get some questions in, so you don't have to listen to my inane ones. So we'll throw you an easy one to start with. Are you working on a new book, sir?
As it happens, yes. The one that is in the works at the moment has an AI flavor, but I won't say too much more because it hasn't been totally signed off on yet, but that's something we're looking at.
Very good. This talk in particular, one of the people here was curious, was it inspired by your work at or with Azure, or is this kind of your own imagination?
It's definitely inspired by the work I've been doing for the past couple of years, because I've been spending almost all my time thinking about organizational style issues, organizational questions, incentives, etc., and also management of people, but really trying to drive change in fast-moving, very strongly growing organizations. So I suppose, as I said in the talk, my intuition, hopefully it's true, is that a lot of DevOps folks find themselves in transition or in change projects or in trying to agitate for no more silos, etc. And they have that component to their thinking and that model of the world, or modeling the world in a way that maybe not all software professionals do. So I was hoping that some of that discussion about what change takes to do would resonate with some of the audience.
Absolutely. So we have time, I think, for one more question, depending on the length of the answer here. And this one I actually wanted to call out because I have it as well. You talked about different models, different ways of organizing, different ways of thinking about, how to do work and how to value work. Is it necessary for a single organization to use only one model, or can an organization implement multiple models? And then I actually want to add on a little bit to that, which is it possible to have hybrid models? Are these things mutually exclusive?
Great question. So by inspection, I think is probably the way I would put it. The larger the company is, the harder it is to have a more consistent approach to what you're doing, particularly because I suppose as path distance increases from some central definition of something, you get stuff around the periphery that's a bit different, and so on. I think my native prejudice is that SRE models tend to benefit more from consistency of approach and consistency of execution than the other models. In particular, you build it, you run it, is very strongly locally scoped. And sometimes that can be totally fine, and it's what you want. The difficulty, as I said in the talk, is that sometimes when you're trying to stitch together you build it, you run it, teams, each of whom are executing with local optimality, you're trying to impedance match between things that can actually be very different. And so my personal preference, I suppose, is that an SRE model where individual teams are varying more, but there's a central core of principles and a central body of knowledge which can be transmitted around and consolidated is really the best of all possible worlds.
Fantastic. All right, so we're actually perfectly at time, as if it were scripted. A big thank you again, honestly, for coming through this evening, sharing your knowledge and your experience with us, being willing to run the gauntlet of a live Q&A. A big round of applause, virtual applause, real world applause for Niall. Thanks again. Thank you so much. Appreciate it.
Thanks.
Okay, so for everybody who's following along at home, and we hope you are, we have a short break. We will resume in about 10 minutes or so. That's going to be 8:10 Kyiv time, whatever time that means to you. So in about 10 minutes. Now, we encourage you to go check out one of those breakout rooms if you're interested in hanging out and getting to know some of your fellow conference attendees. And that's going to be in the YouTube chat if you're looking for those links. Of course, you can also just chill out yourself, right? Again, we're going to be back in about 10 minutes. Stay tuned. Hello, everybody. Welcome back. I hope you had a pleasant break. I hope you had an opportunity to check out one of the Zoom Hangout rooms. I know I did. We had a good time. If you didn't, that's also fine. Your time is, of course, your own. Before we continue, just want to let you know that the music that you may have heard before the stream started and that you're hearing in between sessions is written by a fellow engineer and a member of the Ukrainian DevOps community. His name is Roman Slipchenko. I hope I am pronouncing that name correctly, and my apologies if I'm not. So thank you for providing the excellent tunes for us today. All right. Next up, very, very important, sponsors, right? So I'd like to introduce our sponsor for today. Perimatch Tech is a high-tech R&D center of the global holding company, Perimatch. Perimatch Tech is an innovative provider of future-defining tech solutions in the gaming and entertainment industry. They are committed to innovation and provide the global community with high-quality betting products and a high-quality gaming experience. They have solutions and innovative approaches that drive the company forward in the gaming market, and they remain its basis for success and continued development. Perimatch Tech is an in-depth synergy of technology, business, and sport. I would like to introduce Serhii Kalinets. And again, I apologize if I have messed that name up. Welcome to the stream.
Hi, my name is Serhii Kalinets. I'm technical architect in Perimatch Tech, and today I want to talk about the tools that I'm using in my day-to-day work. This is a teaser video, so I will just name all these tools, and if you register to this event, you will get the link to the full video when I will show these tools in action. The first one is OMZ Shell. OMZ Shell is basically a customization framework for Z Shell that allows you to add thousands or maybe hundreds of plugins and themes to your Z Shell installation. I'm using Antigen to manage these plugins, and if you're talking about the themes, I tried many of them, but each required some manual tweaks, some configuration, and I'm too lazy to do all this configuration. And recently I found the very cool theme. Its name is Power Level 10K, and this one is a key killer for me because I just installed it, made some simple choices, and got everything that I wanted. Next thing is Tmax. Tmax is basically a console multiplexer that allows you to split your one terminal into multiple panes, windows. Tmax is a console multiplexer that allows you to split a terminal into multiple sessions, windows, and panes, and you can see more than one session at one time. This capability are usually provided by tools like iTurn2 or so on, but I think that Tmax is a better option because you can use it everywhere, even in very old school terminal and when you connect to remote servers. So Tmax is definitely a thing. Next thing is BET. BET is basically a clone of the cat utility that allows you to see files with syntax highlighting, and it just adds more color to your console when you are looking at files. Next in our list is ripgrep. This is just a grep, but with some improvements. They say that it works faster, and it's definitely easy to invoke because you need to type only two letters, RG, instead of grep, and it supports regular expression and all the stuff that we use when we searching stuff in the files. Let's move to the next one. This is a diff utility. The name is self-telling, diff so fancy. And diff so fancy is the differ that adds some colors and useful and pretty output, and if you install it, it integrates with Git, and Gits are looking much better than by default. One of my favorites is a utility that I cannot pronounce in this session, so we will name it F-word. So this is basically a thing that fixes your errors when you type different commands. So for example, you do git commit, but instead of double M in commit, you type only one M, and Git returns you an error, and instead of fixing it, You just type this F word and it will fix your input automatically. It also can help with adding sudo in the beginning of and fixes many various errors. The next killer utility is ZJump. ZJump is used to navigate to locations or directories that are most frequently using. So if you perform some work in your work directory or you have some projects that you recently need to navigate to, you can just type Z and the part of the name and you will get right there without any complex trying to remember in which folder this location is, the full path and so on. FD is my replacement for find command. When I need to find some files, usually I cannot remember all the syntax or the options of find command. You need to provide the type of entry you need to find, like whether it's a file or a directory or so on. FD has much simpler syntax and it provides the same capability as find command. And also it's easy to invoke because it has only 2 letters. So I'm using FD to look through my files. However, I have even better option for looking through files and not only files, and this is FZF. FZF is a fuzzy finder. This is awesome piece of software written on Go, and it allows you to filter through different lists, mainly files, but it could be anything. It could be git commits, it could be processes, it could be some handles and whatever. It is very flexible, it can be injected into any pipeline, it has integration with Vim, it can be integrated with existing tools, and this is really a game changer when you are working with stuff in console. This is all for the list, and if you register to this event, you will get the link to the full video when I will show these tools in action.
Excellent. So that was informative, but also really short. If you're interested actually in checking out the full length video on that, Serhiy goes into a ton of great tooling and system administration type stuff. Check out the link in the video description on the YouTube channel. It's right there. You can go check that out. You can sign up. You can win some prizes. It's a lot of fun. Also, I should point out that Serhiy is a pretty popular and active speaker at IT conferences all over the place. So .NET XP Days, DevOps Fest. He coaches and does engineering practices, and he's currently doing system architecture work over at Perimatch Tech. So if you are interested in talking with a specialist in the domain, he's your man. All right. So let's continue. I am genuinely proud to introduce Liz. She's one of the most famous influencers in the site reliability, engineering, and observability spaces. She's one of the key people who made the SRE community so unicorn unique. A big round of applause for Liz.
Hello, thanks for having me on for DevOpsDays Kyiv. I'm really glad that I could be joining you virtually. So I'd like to start off with a riff on a nursery rhyme that we have in the US. I'm not sure whether people read Dr. Seuss in Ukraine, but this is the rhyme. Congratulations, today is your day. You're off to observability, you're off and away. You have brains in your head, you have hands on keyboard, you can steer yourself any direction you go toward. But what direction should we go toward as people who are developing systems? As Niall said in the talk right before mine, there's definitely a lot of concern over making sure that we're building the right things. And once upon a time, Niall and I both worked at a company that duplicated a lot of work. There were 20 ways to do anything. There were 20 ways to run your commands inside of a homegrown Kubernetes environment. There were 20 ways to add monitoring to your software. And everyone cared about mottos like fanatical support or focused on the user first and all else will follow. But That's really challenging and hard to do when you can't see into your systems and you can't understand the impact of what you're doing. So this road to happiness turns out to actually be taking you towards pain if you don't set the right incentives for you and for your team. That if you're setting the wrong incentives and promoting people for building things that don't actually add value, then you're creating a lot of problems. Organizations tend to do things like have an attitude of, if this wasn't invented here, it's not good enough for us. That nothing else could possibly solve my problem because I am some kind of special snowflake. And maybe if you're Google, the answer might be, okay, we need to build one new way of doing things, but surely we don't need to build one new thing for every team at Google, never mind for the entire industry. People also wind up doing things like building projects that are only for the purpose of getting a promotion or for making it look good on their resume. We have too much autonomy almost over the tools that we're building, and that causes us to waste our time. Or the flip side of that is also disempowering. If you have too little autonomy over what you're building, because people are telling you, just trust the consultants, use whatever people tell you to use, where people feel like they don't have control and the ability to make their teams and working environments better. Today, I want to tell you that there is a better way to think about building software as a DevOps team, and building software specifically in the domain of observability, as well as around automation and many of the other things that we care about in terms of culture, automation, process, and measurement. So what's our goal as DevOps engineers? What's our goal as site reliability engineers? Our goal is to make sure that our products have appropriate reliability and scalability, that our products are delighting users, and that we're able to ship fast enough and to ship them what they need and have them be able to depend upon the tools that we're giving them. So this often takes the form of making sure that not just that our machines are appropriately scalable, but also making sure that our people are appropriately scalable, that we're not baking in too much complexity to the point that our people can no longer keep up. We should make sure that no team has to do too much ops. Not just, hey, my software development team shouldn't do ops, let's push that onto the call center, right? Like, no, we need to make sure that everyone has to do the right amount of operations. This doesn't mean we do no operations, right? We have to have some exposure to production to understand what the requirements are in production to make sure that we're building things that are informed by what the production experience is. So it's this constant trade-off between essential complexity relevant to the features we're building versus getting rid of unnecessary complexity that has crept in, which is also known as technical debt. So we need to have service level objectives, which are covered in the Site Reliability Engineering book. But to summarize SLOs really quickly, this notion of appropriate reliability and scalability revolves around defining as a product requirement, what is our objective? Are we aiming for 99% reliability, 99.9% reliability? And how exactly are we measuring it? So once you've done that, you also need to think about what appropriate observability is for your system. Your observability requirements are probably much higher stakes if you're operating a 3 or 4.9 service than if you're operating a 2.9 service. You really need that control loop over your data in order to understand and be able to debug those novel cases in production, to understand, why is my system behaving the way that it is? Can I take it apart and understand what's happening without having to push new code? This is not the logs, metrics, or traces that you use for instrumentation. This is instead that broader socio-technical capability of, can we understand based off of the data that we have and our mental capabilities and our tools. It's also not just the notion of break fix or repairing things once they're broken. We do need operational resilience, it's true, but we also need to think about pushing things left, shifting that effort left, so that we get observability into our code as we're developing it, so that we can adopt not just test-driven development, but observability-driven development even before the code gets checked in, so that we can understand, as our code progresses through a continuous integration and delivery pipeline, where is it getting bogged down? Why is my CI/CD pipeline slow? Why is it flaky? And even better, can we get insight into what users are doing with the features that we're building so that we can measure and know if our projects are having a positive impact in delivering return on investment? And can we understand and proactively manage that technical debt so that we understand what are the dark, scary areas of our system that we need to improve, that we need to streamline? As I alluded to earlier, observability is not just the data. Observability is the broader capability. Do we have the right ability to add the correct instrumentation to our code in an ergonomic fashion? Is it as easy to add the appropriate observability as it would be to add a printf debug line? Can we stream that data to a data source that is easy to use, that is easy to maintain, and doesn't suck up all of your time? Elk. And do you have the ability to make it scale cost effectively without eating your entire budget? And then can you query it, both from a technical perspective? Is your data storage engine capable of generating the responses to your questions about continuous delivery, about operational performance? Or is it limited to a fixed set of questions? And do you, as an individual person using the system, feel you're empowered to do so rather than just using a finite set of dashboards? Are you, as an operator of the system, able to go and dive into that data? So we need to make sure that we, as a team that builds tools, because DevOps teams get their highest leverage through building tools, are we taking ourselves out of the picture? Can product development teams successfully push code without needing to talk to us? We are a scaling limit ourselves, so don't make systems that depend upon cloning yourself. We need to make sure that as we engineer observability and broadly automation systems in general, that we're making sure that we're engineering for all teams and not just shoveling work onto other teams or help desks. That reinforces the bad days from before DevOps. And moreover, engineering is not just the art of writing software, it's the art of maintaining and cultivating and building the broader capabilities on top of existing software. So what is the problem that we're trying to solve here? We are trying to solve this problem of getting so much software duplicated. How can we fix this? Well, we can change the incentives. We can, instead of rewarding people for doing the wrong things, reward people for doing the right things. If I come to you and say, hey, look at this thing that I threw together with duct tape, you should look at me askance and say, hey, Liz, maybe you should tell me not about the kind of cool thing you duct taped, but instead you should look at the actual success case, right? Like, what was the problem that we solved? How are we successful? How did we get to this problem, right? What was the situation and context around it? What did we try, including the dead ends? How did we actually solve it, right? Like, what are the solution pieces that can be reused by other people? And how did we actually make an impact on our teams? Did we streamline the workflow and save 30 minutes off of every deploy, making every developer much more productive, right? That's impact, not writing 100 lines of code or 1,000 lines of code. So look left and right first before building. Don't necessarily jump straight to writing code. And don't glorify creating complexity. It used to be at Google that the job ladder said, you get promoted from level 3 software engineer to level 4 software engineer if you have the right amount of complexity in your design docs and complexity in your code. Turns out that incentivizes people to build throwaway projects that wind up adding complexity to the software ecosystem and not actually solving problems. So remember, open source exists. You can borrow from open source or just adopt it wholesale. Your coworkers' code exists. Don't build the same things 20 times over. Maybe if you're Google 3 times is enough to account for all possible use cases within the company, but you're probably not Google. And vendors exist. Is this a strategic advantage to my company to be building this? If only I can build it, then I should build it. But if this is something that anyone else could do, let other people do it. Let them specialize. So you may be sitting here saying, okay, Liz, this is... I cannot tell you what to do. Your situation individually is unique. But here are some of the questions that I might help you with if you came to one of my office hours. I might ask you, not just what problem are you solving, but things like, what problem are customers having? Your customers are probably not complaining that they have too few dashboards and they need more dashboards. Sometimes the customer is you. In fact, sometimes the customer is your own team. Sometimes it's an engineering team. Sometimes it's end users. But regardless, you need to hear from end users. And specifically in the domain of observability, we are not just trying to do metrics and traces, right? Like metrics and traces are not the goal, right? They're not the how, right? We need to focus on why. Why are people having a problem and how can we help them solve it? Don't dive in too deeply into implementation details. Developers moving faster is our goal as DevOps and SRE teams. That's how we wind up thinking about serving our end users best. So think, why? Why are users having problems? And then after that, how can we fix it? Who's going to run the solution that we build? We have to think about, is this something that's going to become crusty over time because too many different teams are running it and each running into trouble? Who's going to maintain it in the code and product sense, right? You have to make sure that it's not a collection of random features, that it's a coherent product with a maintained code base. And what options are we considering? And think a lot about, reuse, open source, vendor, or build new. And a shout out here, for instance, to Etsy, one of the e-commerce vendors in the US, that chose Google Cloud Platform over Amazon and Azure and explained in detail in a public blog post so that other people wouldn't have to repeat that work. And it's okay to have not just one thing solve it, but you have to think through the options, right? You have to decide, what? I can build this correctly out of two existing things rather than building a third thing myself. So adapt an existing solution or two. Sometimes the right answer is build on more than one thing or extend something existing rather than starting from scratch. Remember that writing new code ultimately winds up creating technical debt, especially if it's bespoke. But if you upstream that code and make it part of the broader community effort, then it becomes an easier lift for everyone to maintain. Don't be that unnamed finance company in New York that maintains its own Kubernetes fork. That's just ridiculous. Running software, as we know as operations professionals, is technical debt. Who's patching it? Who's keeping it up to date? This is why software as a service is so helpful. Because it means that one set of people is running software for many different companies instead of each company running the software itself. As Niall said in his talk, a third of projects wind up being net negative for a company. They generate negative value because they've built the wrong thing and it's ruinous. If you're a startup like Honeycomb, we're a company that has 30 employees and has received less than $30 million of funding. If we build the wrong thing, that could sink the company. So how can we avoid that mistake? Well, we have to collaborate with the broader DevOps and observability community. We have to listen first. We have to do user studies. We have to approach the art of site reliability engineering and DevOps engineering as a product management concern. Are we gathering product requirements and doing user studies before we actually start building? Are we looking around for similar problems that have already been solved? And if we made sure that we're not closing off avenues to build and extend, even if we're not necessarily building that scope today. So focus on extendability without diving into feature creep. And maybe you'll find existing solutions by looking left and right before you actually start building. The other thing that we can really do to empower users is to document things and provide examples once we've built something. And that applies even if we haven't personally built it. If you adopt an existing open source technology and you work at a company, document how Fastco uses foobar, because other people will rely on that and be able to avoid duplicating that work. Documentation includes working examples. People copy the first instance they find of a working application, so make sure that your examples are good, or else they'll set people down the wrong path when they copy an outdated sample application. And really focus on upskilling and training each other. An active users community is a real force multiplier. For instance, Honeycomb, my employer, has a Slack community called Pollinators, where we learn from each other, where users help each other, and where they contribute open source fixes. That way people feel empowered to improve and extend the tools that they work on rather than treating them as black boxes. User confusion is really costly. It's not just a matter of writing good documentation. It's not a matter of, oh, there's a workaround for that, right? Like, make sure that people know that they're empowered to make things better and that we're going to streamline things to reduce confusion. So this was a problem that we faced in the observability community. We had competing products. We had open census and open tracing that were both competing with each other as well as with proprietary solutions. And people had no idea which one they should adopt. But we simplified. We decided that we were going to found a new project called Open Telemetry to consolidate both of these standards and put it under the Cloud Native Computing Foundation. And that way people were learning about how we could work together even as our companies were competing to provide solutions. So now there are dozens of different companies that are all contributing to this, ranging from vendors to end users to open source communities that are all making OpenTelemetry better, allowing both the users and the providers of telemetry solutions and of observability solutions to make their lives better. So that they only need to instrument once. They only need to write the instrumentation for open standards and open libraries once. And that way everyone has an easier time getting visibility into their projects. So share with your community. Yes, like the set of people here, talk about your wins. Let's celebrate our wins. Let's use the same language and APIs to talk about kind of what are the technologies that we're using, what are the problems that we're solving, and make sure that we're not constantly renaming what we do. Don't dump hacks on the community, right? Do not treat the community as a dumping ground. Instead, we need to say, this is what something is useful for. This is what the right solution is in my case, and this is whether or not it's the right thing for you. Don't let people waste their time evaluating something that's just not going to work for them. And upstream your code and specifications. Don't maintain separate forks. If you publish an open source project, make sure that there's more than one stakeholder so that it's not just a single company project. A single company project is doomed to failure. Eventually that company will go under and then nobody will be able to maintain it anymore. So make sure that you have an ecosystem built around your open source project. Document what you build and why you've built it that way. Have RFCs or technical design documents to explain kind of what we did, why we did it, and why our decision might be subject to change in the future. Overall, though, what I'm here to tell you is that you don't have to be a hero in order to operate a successful DevOps team. You just need to make sure that you have the ability to build software in a sustainable way that's documented, is supported by the community so that you can choose to move on and take a new job, to go on parental leave. The world should be able to go on without us, so automate away your previous job. Here's what happens if we do it well. If you do things well, then you'll have a very low change fail rate. You'll have a low time to restore service. You'll be able to ship code quicker. But unfortunately, a lot of the industry is falling behind. From 2018 to 2019, the number of low to medium performers actually increased rather than decreased year on year. Last year, for instance, there were 52% of teams at software organizations that were medium to low performers. This year, there were 56%, right? Like that number is unfortunately going up. However, we're doing a great job as people who are connected with this DevOps community of helping upskill people from high to elite performers. It's just that that movement is mostly still within the medium to low performance space. So let's reach out to people who are not involved in the DevOps community and get them involved with the DevOps community. Teach them what we know. Teach them what we know about build and unit tests being really essential. Teach them what you've just learned about observability being really, really key to understanding what's happening inside of your systems to reduce your time to resolve incidents. So here's our story at Honeycomb. A dozen engineers are responsible for building Honeycomb. And we're a product that serves in the millions of events per hour, right? Like we're a system that manages to ingest data at scale. We help software teams make their systems humane to run by ingesting your telemetry and helping you get insights into what's happening inside your system so you feel empowered to fix issues and be proactive. Observability is our superpower, and we hope it becomes your superpower too. Yes, we deploy on Fridays. We deploy every single day of the work week, Monday through Friday, and we are able to take weekends off without emergency pushes. This is our real deployment frequency. We deploy a dozen times per day. And when there is a problem, we're able to push changes within 3 hours for a routine change. And we're able to push code every single hour with only 1 or 2 new commits per build artifact. If there is something that we need to fix, we can often fix it forward, but if not, we can do flag flips. And emergency rollbacks are only needed 0.1% of the time. Less than 1 in 1,000 changes catastrophically fail for us. And flag flipping takes less than 30 seconds. Pushing a previous build takes less than 10 minutes. And our continuous delivery system is set up so that we can fix forward in less than 20 minutes. So high productivity product engineering is enabled by continuous integration, continuous delivery, flag flips, and high degrees of observability so we can understand immediately when something's gone wrong in production. You too can do this. You just need the right building blocks. You need CI and CD, obviously, and you need the right set of telemetry. You need things like OpenTelemetry in order to help you get that data baked into your application code and sent to the right set of data sinks for analysis. So I'd encourage you to check out OpenTelemetry. And I'd also encourage you to think about the overall big picture. How can you write less software by building off of open source tooling and using software as a service in order to empower you to focus on what really matters? Look around you, evaluate things, collaborate with the community, and share what you learn with the community. For any of you who are having trouble viewing my slides earlier, they're at honeycomb.io/Liz, where you can scan that QR code on your screen now. I'll also put it in the YouTube chat. And thank you very much. I welcome your questions. And thank you very much for your attention.
Thank you very much. That was a very high-speed talk through a ton of material. I don't even know where to begin on the Q&A. I was furiously taking notes, to be honest with you. So while we give a moment for the community in the YouTube chat to hit up Slido, and again, if you want to ask Liz a question, it's in the YouTube chat, the link, go to Slido, feel free to ask a question. I'll kick us off here, and I'm going to kick us off right at the very end. The CI/CD pipeline and procedures you were describing, that sounds great, darn near magical. Can you provide any insight into what's going on behind the scenes there?
Yeah, I absolutely can. So I think that the key element of our CI and CD process has been actually adding distributed tracing to our CI/CD system. We have a library for that called build events that's integrated with things like Jekyll Index, Circle CI, Travis CI, that adds kind of start and end markers to every step of our build process so we can see what the bottleneck is and reduce that bottleneck. So we know, right, like if a step is taking 30 seconds, reducing it to 15 seconds doesn't make a big difference, whereas a step that takes 10 minutes, we can reduce to 5 minutes and really dramatically cut our time to build. So that's kind of one approach that we've taken. The other approach that we've taken has been being really, really attentive to build failures, right? Like to make sure that we don't have flaky tests, that we often don't need to rerun tests. And that enables us to do that hourly push with minimal lead time because we have high confidence in our tests without needing to do manual testing. And the tests run quickly and they're able to produce golden artifacts that we're immediately able to deploy. So I think that's kind of how we get to that hourly push, right? Like is making sure that those tests are high fidelity and that we've instrumented them to make sure that they run quickly enough.
You almost make it sound too easy. But no, that's great insight. Thank you.
Right, like I
honestly,
guess it's kind of interesting. You know, people think that Honeycomb, employs super elite engineers, right? It's about the team. It's not about the individuals, right? It's about our processes and about what we prioritize as an organization.
Fantastic. That sounds great. So we got some questions coming in from the Q&A, the Slido. One here is well upvoted. This should be fairly straightforward. Is flag flip the same as a feature switch or a feature toggle?
Yes, that's correct. It's a feature toggle. Yep. So we happen to use LaunchDarkly. We really love LaunchDarkly, but you can also use tools like Mode. You can also use kind of other tools.
Excellent. Another +1 for LaunchDarkly, by the way. They're doing great work over there. Another question from the audience. What would you, Liz, recommend on where to start with improving your observability? What would be the first steps?
Yeah, I think the first step is really kind of moving away from just logging things with log verbose spew. You kind of want to apply structure to your logs. You kind of want to make sure that you are emitting JSON logs rather than kind of free text, that you're emitting no more than one log line per kind of request through a microservice, right? So kind of combining those discrete log events into wide events. And then once they're kind of wide events, one per event flowing through a microservice, each with kind of discrete fields, like, the HTTP code is broken out separately from the user ID, is broken separate out from the request ID, is broken separate out from the kind of request status, right? Like once you break those things out, then it's easy to feed them into a tool like Honeycomb, for instance, or Jaeger, or anything basically using OpenTelemetry, right? That enables you to get that more robust data analytics, and then eventually build distributed tracing on it, right? Like because once you have a kind of wide event, it's easy to say this is the parent ID. So a lot of that work has been done for you if you adopt OpenTelemetry or similar, because it means that kind of that instrumentation library has been thought out. It's a relatively easier API to use than trying to invent it yourself. That's why, in my talk, I focus on, not inventing it yourself. So I think that's that. And I think also I'll put a link in the chat that talks a little about that process of improving observability, transforming from logging into tracing.
Excellent. And again, +1 on that one. Strong advice there. Do not try to write your own version of OpenTelemetry. Down that path lies madness.
Yeah, and I have to say, thank you to Datadog for donating your automatic instrumentation libraries, right? Like, that kind of is very much in the spirit of let's not write auto instrumentation 5 times over. Thank you, Datadog, for donating that to OpenTelemetry. We're all richer as a result of it.
That literally the idea. So thanks. So I've got a couple questions actually that I'd like to, just for my own edification. So I'm going to use my soapbox here. You mentioned you had a slide on what did we try and documenting what was tried and how that went. I'm just curious, what, if any, are some techniques, processes, strategies for discovering what was tried and recording what was tried and having an honest discussion about those determinations?
I think that it's super great to write down not just the results of successful experiments, but failed experiments. For instance, I tried this month-long project about a year ago to run our Kafka brokers with solid-state drives as their primary storage and having hard disks as their backup storage using kind of a warm cache approach. And it backfired extremely badly, right? Like, we discovered that the median latency was great. The 99th percentile latency was awful, right? And that it was slow enough to stop our Kafka from processing at the correct speed to maintain the quality of customer experience, right? But I meticulously wrote down the results of that experiment and put them in design docs so that anyone else who followed along could see why did we pick, a certain size of instance, right? So we decided we were going to move off of Amazon EBS, but that we were, instead of moving off of Amazon EBS solid state to Amazon solid state with the kind of cold storage backing it, we were going to instead just use Amazon i3 instances, right? Like that was a design decision that we documented. And now, interestingly enough, we're revisiting this today and having those notes from a year ago of what didn't work, right? Like was really, really helpful. But, if I hadn't been here, right, like, now today, right, the engineers would still be able to read the design docs to understand why.
Right. So that sounds really good. Documenting not only what was tried and worked, but also what was tried and failed. Super critical, for sure.
Yeah, and also, right, like under what criteria we would revisit the decision, right? Like decisions that are technical are not forever, right? They're maybe for 6 months, maybe for a year, but at some point you want to revisit that decision. So knowing what has to change in order for us to revisit this, rather than this is the way you've always done it, right?
For sure. I mean, organizational dogma is the root of all evil. It's good to be able to look critically and especially with a bit of an eye askance to history. That's super important. So last question before we leave, a hot button topic for people all across the industry: deploying on Fridays. You mentioned in your talk that this is something you do. What is, everyone has an opinion here, right? Why does Honeycomb feel comfortable with the decision to go ahead and deploy on Fridays?
Right, like it's a little bit more nuanced than we always deploy on Friday, right? Like the decision is use an appropriate amount of judgment when deciding when to deploy, right? Regardless of whether it's Monday or Friday, you probably don't want to deploy a risky change at 5 p.m. and then walk out the door 10 minutes later, right? Like you kind of have to let it go to production, have the appropriate observability to watch it as it hits production, make sure that it's looking good, and then after that you can sign off, right? So I'll push a risky change, on Friday at 3 p.m. I won't push a risky change on Friday at 5:55 p.m., right? Like I think that's kind of that judgment call of knowing how risky is something and can I observe it to measure the risk and to mitigate that risk? And if you meet those criteria, right, like then you should be able to proceed. So it's about not artificially imposing rules like no deploys on Fridays, but instead enabling people to have the tools that they need to make that judgment call. And ultimately, at the end of the day, if you do that successfully, right, it doesn't matter which day of the week that you push something because, if it could blow up 5 days later, it could equally blow up on Saturday or on Monday. So it doesn't, right, like it doesn't really matter, right? Like it's equal risks. You may as well do it because at the end of the day, you need to ship features to your customers, right? Like, and if you are slowing down artificially because your build system or your observability is lacking, right, you need to go back and repair that build system with observability. Charity and I aren't telling you deploy on Friday when you're not ready. We're saying that if you're not ready to deploy on Friday, examine why rather than just treating it as dogma.
Right, fair enough. So treating this argument of deploy on Friday as an artifact, not as an end goal. That's
yeah, exactly.
an interesting way to look at it, actually. Yeah, right on.
Like,
Thank you for that.
What's the problem we're trying to solve, right? The problem we're trying to solve is we need to ship code at a reasonable speed to delight our users, right? What's standing in our way? How can we avoid that? All the automation in the world doesn't, that's mistargeted is a waste of your time, right? Like, you need to solve the actual problem.
Fair enough. Excellent. Well, hey, you know what? We are bang on time. So that's it for the Q&A for now. If you have more questions, and I'm sure you do, and I know you do because they are in Slido, Liz has made available on honeycomb.io/Liz all of the information and things that she's worked on. She's active on Twitter. I'm sure you'd be happy to engage people there in